All right, let's go ahead and look at our first lesson, week 1. So I've already opened up the Anaconda program. I'm in my web browser looking through my files. So we're going to go ahead and find week 1 student lesson. So let's see, we'll call that up. I'll let you read this beginning part on your own. I want to just kind of highlight a few things here. So writing your own functions, I'll give a couple of examples of that. Of course, by now you've already watched the videos that were recommended in Canvas. That's really going to get you started. Here I'm just giving a couple of pointers. So one of the things we'll find is that for much of what we'll do, we're going to need to import one package or another. And the one package we'll probably import in almost everything is called Numpy. Okay, this is one of our scientific packages that handles numbers, and a lot of times we will, by convention, import NumPy as NP, the NP being an alias, so we don't have to type out NumPy. And again, this is a convention that's used, so I recommend it. And then if we want to use functions such as the mod function, and if you don't remember, mod function just simply returns the remainder. So if I have a number 10, say here, 10 mod 3, so 3 goes into 10 3 times with a remainder 1. So the mod would return 1. If the mod function doesn't have a remainder, then that means that the number x would be divisible by 3. Okay, well, that mod function doesn't exist in Python directly, but it is in NumPy. And so we will tell it that we're going to use the NumPy package NP and use the function in NumPy called mod. And so that's the general format you'll see all of the time, sort of package, dot, and then function. All right, so in this case, we're going to write our own function, and we've got this definition defining our function. We got the name of our function. It could be anything we want. The variables that we're going to need in our function, if there's more than one variable, then just separate them with commas. And variable names, again, can be anything you want. And we're going to use an if-else statement here. So we're going to say, all right, if this x value that's passed is divisible by 3, so it has a remainder of 0, okay, so the double equal sign is a test, testing whether this is 0, then we'll print, yes, x is divisible. If it doesn't equal 0, then that means it has a remainder, and so we don't need to test for that case. We just know it's else. We'll print no, x is not divisible by 3. Okay, so we got to run this, so don't forget we got to run this import one first. All right, then we'll run this definition, and now we can use it. So we could put in 18, it says it's divisible, 19, no, it's not divisible. Okay, pretty simple function. One of the things I'd like you to do when you're working with these notebooks is, don't just sort of read these passively and run the lines, but test them a little bit, right? So, here's my function. What I might want to do, maybe so we don't mess this particular function up, we'll go ahead and I'm going to add a line here. We'll go ahead and copy it down here, and we can play with it a little bit. So, one thing I might try is let's go ahead and change it, and let's call maybe our function even, or maybe more descriptive would be is even. Okay, so I'm just testing whether I understand what's going on here. So if I want an even, to test whether something is even, then I'm just going to do the mod here, and I'll divide by 2 instead, right? If I have no remainder, it's even, so x is even, and otherwise, else, it's odd. So we'll just change this to x is odd. Okay, I don't want to change too many things at one time. This is a comment, so maybe I'll just delete it. Okay. So I'll run it, and now I'll go ahead and I'm going to add another line below it, and I will go ahead and use my function is even, and I'll pass it an odd number, say 5. Okay, x is odd. All right, maybe we give it a, even number. X is even. Okay, so that's working. Okay, so this is the kind of thing you want to do. So we've tested, at least whether we understood that this is something we can change. If we're wondering about the variable, and maybe I put something else in here, y. Well, that would mean that I just have to make sure I use that specific variable everywhere. Okay, run it again. Yes, x is even. All right. In this case, okay. Anyway, just notice the format. When we're doing a definition, we have to have a colon. When I'm running this if statement, I have to have a colon. The else has a colon. And also notice after this, I'm indented. My next line, so everything underneath that's been indented falls under this definition. Same with my if statement. Anything indented below it falls under that if statement. And then my else. So, I might want to check. Let's say, well, can we have more than one? Let's just print hello here, okay? All right, so let's see. If we have an odd case, like 5, it just says no, x is odd. Even case, yes, x is even, and it prints hello. So looks like I can put any number of lines here I want as long as they're indented. Well, let's test that as well. What if I don't indent it? What happens? An error. Okay, so we can see that we do need the indent. I'm getting an error, and it says expected an indented block. So I'm going to go ahead and put that back. All right, so that's the kind of thing that you should do as you're reading through. Take it, modify it one little bit at a time, run it, and make sure that you understand what's going on. All right, so let's move on then. One of the things we'll see with print statements is it's often nice to actually have a variable like x and return that value in the print statement itself. And one of the ways we do that is with what's called an f string. So you'll notice the difference here. Up here we just have print, and then in our quotes we put in the text we want. Okay, down here we have print, and I shifted the quotes. It doesn't matter which ones you use in Python, but let me just put these in double quotes like the previous so you realize it doesn't matter. I didn't switch for any particular reason there. But what I did do is put an F out front, and this tells it to expect a special string called an F string. And what it'll do is it will look inside of the string for anything that is in the curly braces, and it knows then that that is meant to be a variable, and so it will look for the variable x outside, and if it has a value it will stick it in. And that's really all there is to it. So if I run this one, now I get, yes, x is 18 is divisible by 3. Okay. If I was to go in and change the variable in here, so even my test is still working, but I've changed it to yy, let's see what's going to happen. I get an error. It says name x is not defined, right? So it'll give me that error. It says it doesn't know what to do with this. And that's because our variable is now called yy. Oops. All right. So we tested that a little bit. Okay, so things seem to be working. Again, play with this, change things, and see if you're happy with it. Log functions, like many programming languages and math packages, the function log is actually a natural log. So when you do type something like Numpy, let's say we do the log of 10, right? If this was a log base 10, then the log of 10 is just going to be 1, right? Let me run this, and you can see, nope, it's not the case. So this is actually the natural log, right? This is the value e. All right, so we could, if we wanted, write our own functions, and that way we could use ln instead of log, and if we wanted the base 10 log, then we can go ahead and use the numpy log base 10 function. And so that's what we're doing there. Now notice it's okay to use the same name that's here because we're defining this log as being in our notebook space if you want. So when we call it, there's no NP out front. If I put the NP out front, it says to use the function log inside of my numpy package. So that would give me a different answer here. Right? So log of 100 is 2. NP, that log, right, would give me a different answer. Okay. Some looping. So you saw some in the videos. I'm just giving a few examples here. We can do simple for loops where for x in, and then we give it a list. So x, the values in here will one at a time be put into x, and then whatever's under here and indented, it will run. In this case, just a print statement. This one doesn't put the values, they're not held in any particular variable, they're just simply printed. So if I wanted to have access to them, then what I might do is initialize a list, a variable called y. Okay, it has no members right now. And then I'll say for x in these same list of variables here, I'm going to take y, and then what I'll do is append x squared to it. Okay, so y originally has to exist in order to be able to append to it, and that's why we're doing this. So it'll append 3 squared, and now it'll come back through and it'll append 4 squared to it, and then I can print my entire variable y. Okay, so y actually exists now. If I was to just simply type y, right, it's a variable that has that list in it. All right, last one is what's called a list comprehension. It just is a shorthand way of doing sort of a for type loop. And the key for list comprehension is just to make sure you've got these square brackets around what you've got in here, and that tells it to go ahead and make this a list comprehension. And the way to sort of think about this is the output. So this says, give me x squared, okay, the result x squared, for a variable x, and that variable x should be taken, or it's in this list. And so calculates x squared based on an x in a given list, and that's the format for it. Okay, and there we go. Okay, I'll see you next time.